Alright, so what if you wanted to determine the stereochemistry of a Fischer projection like this? Because we haven't seen this before. We've seen determining stereochemistry of a normal wedge and dash representation, but there must be a way for doing it here. And there is. We're going to use this when we look at sugars too. So there are basically 3 steps, the second of which I'll give you a bunch of help with. The first you've done before, the third you've done before. So we're just going to go ahead and do that. Let's look at our priorities, okay, and assign priorities as normal. So remember, we're looking at atoms directly connected to this central chiral carbon. So therefore the amine is priority number 1, hydrogen is priority number 4, the acid's priority 2, and the methyl is priority 3. So that is step 1 done. Alright. Now step 2, this is very similar to the Pennington method that you've seen before. The only difference is, in doing the Fischer projection, if you remember on the previous video, the dashes represented the atoms pointing up and down. Specifically the one pointing up here means the atom pointing away from you. So you want to rotate around a certain part of this molecule to get the hydrogen up on top. So we're going to use the Pennington method. And really I could clamp here or I could clamp here. I can't clamp here because I want the hydrogen to get up here. So I'm just going to say let's clamp the let's clamp the methyl group. Alright, so we're going to clamp around here and then rotate. Doesn't really matter if we rotate clockwise or counterclockwise. And here is the beauty of it. It's just like the Pennington method when assigned to other molecules. We know the CH3 is going to stay where it was because we clamped it. We know the hydrogen is going to end up here because that's where we said we wanted it to be. We know the NH2 was here originally, so it's got to be somewhere else, and the only other choice is on the left, is on the right, sorry. So therefore, the only possibility for where the CO2H goes is here. Let's put our priorities back on again. 1, 4, 2, and 3. Alright. And then all we're going to do is to say we're going to actually we've just done step 2. Now we're going to do step 3. We have the hydrogen where we want it to be, then we're just going to count around which direction we go to do 1, 2, and 3. So we go to the left, 1, 2, 3 like this. So therefore this is S. And that's a simple way to figure out the stereochemistry around a Fischer projection carbon. Now let's just check though that that's right. Let's do what we did in the last video and convert this into the corresponding wedge and dash diagram. So here we go, CH3, here's our NH2, and here is our CO2H, which we're going to then convert using the method that we used last time. I'm going to put the NH2 up on top here. We'll put the CO2H here. And if you can see, this is exactly why we move things so that lowest priority group, the hydrogen, goes on top, because that ends up being this group here. And we've got our CH3, so let's put our priorities on. Priority 1, priority 2, priority 3. And as you can see, we were right before, because this just clarifies what we said. This is indeed S. This was actually problem 21.2a from the textbook. So if you can do that one, you should be able to do the others. Alright? Now, I said we were going to expand this. So can you apply the same logic that we've just been through to figure out the stereochemistry at each of these 3 chiral carbons in this sugar. This is an aldopentose, in that aldo means there's an aldehyde at the top. Pent means there's 5 carbons, 1, 2, 3, 4, and 5. Ose just means it's a sugar or a carbohydrate. Now you guys can see the number of chiral centers here, can't you? That's 1. That's 2. And that's 3. Usually in a sugar like this, the top carbon and the bottom carbon are not chiral centers, but everything else in between is. So what I would do is just do the Pennington method 3 times, alright, 1 for each carbon. And so for this carbon, this group will be this will be this, and this will be this, and then the rest of it will be this. So if we just assign priorities here, priority 1 would be the OH, because we're talking about connecting to this carbon. Priority 2, sorry, that would be priority 4. Priority 4 would be the hydrogen. And then there's a carbonyl carbon coming off this carbon. There isn't here, so this is priority 2. And all this is priority 3. And then you can just do the Pennington method. Do it for this carbon, and for this carbon. And hopefully what you'll find, and so you want to check that this is actually right. Well, I know it's right, but make sure that you convince yourself that it is right. This stereochemistry is R, this stereochemistry is S, and this stereochemistry is R. Usually what that means is, for a sugar like this, the OH pointing to the right is an R stereochemistry, the OH pointing to the left is a H stereochemistry, with the OH pointing to the left is a S stereochemistry, sorry. And that's it. So have a go and see what you can do.